There we go. Let's begin again without any mention of vegetables. Let's see here. I don't know what's going on with these vegetables. What's that? Any question? So, all right. So eventually, everyone will find their way into the homework. I believe it's going to happen. It will happen. And that's important because you definitely need to do the homework before test one. Otherwise, test one will be very mysterious. When is test one? Let's see, yeah. September 15th, which is, how long is that from now? Yeah, 12 days, right? I mean, is there a lot of stuff on the first test? Well, how many questions? Enough? I mean, I was told I can put one question. If you just want one question, I can just put one question. That's right, but that one question is going to have A, B, C, D, E, F, G, H, I, J, K. I mean, joking aside, I usually have about like 3, 4, 5 pages for a class like this, something like that.
So you're talking about like 40.
40. I don't know. I mean, it's not, the number of questions doesn't matter. The you know, when I make a test for any class, I always try to make sure that the test has, you know, has covered all the things that are covered in the homework, you know, and and reflect what we've done in class, you know.
Do you have like a tutor for this class? Like, is there like a tutor coming to me?
No, I understand this stuff. I'm pretty good. Oh, for you, for the students, the tutor. Oh, yeah. No, the Math Help Center downstairs, they can tutor, and they do. They have. I see them sitting in there. They look lonely and bored most of the time. They're just itching to teach people math, you know. You can tell them about any kind of vegetables you want. I'm sure they would love it. But no, I think it's the I can't remember the name of the place, but it's downstairs and like at the end on the end of the hallway. My math lab, or just says math lab. This my math lab homework. It's in my brain. I can get it out. What's that? Words aren't green. Something like fall in love with math. I think it says fall in love with math, doesn't it? No, they got a bulletin board that says fall in love with math. They spent hours. You better acknowledge that. They spent hours putting that up. I saw them. Cut out little leaves and stuff. Oh, the worst subject in school for me? A recess. No, I don't know. No, I'm sure it was English. I mean, you know. Oh, yeah. English is hard. It's all like contradictory, you know, like they got different rules. There's always an exception to every rule, you know. There are no exceptions, though. It's just the rules are universal. Oh, so you guys are distracting me with your jibber jabber. So test 1 covers chapters 1 and 2, and let me read the list of topics. Chapter 1, sections 1 through 1.1, 1.2, 1.3 are on equations. 1.4, 1.5 on sets, inequalities, and interval notation. Oh, and if you're wondering, I'm just reading the course planner, which I've posted in course content. Right, the course planner goes day by day with what we were talking about. So, and you won't. And by the way, you won't see anything in black. Like your other courses, you might have things in the Blackboard calendar showing up. That's because they're like doing quizzes or something in their course through Blackboard. I do none of that. So like Blackboard calendar will never show you anything about my course because I do everything outside of, the only thing I use Blackboard for is to share files with you, like solutions to test and stuff like that, and to record grades. Like when I grade your, quiz 1 and test 1, I will put those in Blackboard in an appropriate column, at the very end of the semester or sometime later, I will take the points you've earned in my math lab and transfer them over to like an appropriate column in the grade center in Blackboard. But that's kind of all I do in here. Besides making announcements, right? Like the announcements in Blackboard. But other classes, you might actually have assignments through Blackboard, right? Where you're uploading essays and stuff like that. Wait, I don't have any essay in here. Do I need to add some? I mean, I could add like a 10 page paper on like history of algebra. 10 page paper on history of the square root? No.
Can we do that instead of a test?
No, we're not going to. No, you don't want me to do that. That won't help you. You really. I will eventually get the class back. Give me a second here. All right, so course planner, course content. That's under course content. So, so basically, chapter 1, we cover sections, I think all the sections, 1.1 through 1.6. There we did equations, inequalities, interval notation, number lines, right, absolute value equations. And then chapter 2, we talked about graphs of equations, graphs of functions, domain and range. And then most recently, linear functions, graph slope, how to graph linear functions and find their slope, etc. And of course, how to find equations of lines. That's it. That's test 1, that material. So what I'm trying to tell you is I have already covered all of those topics in lecture, right? So from here on out, it's just basically review of stuff we've already done until test 1. And then after test 1, we'll go on to bigger, better things, But just wanted to let you know, where we are, where we're going. That's out. Any questions? Yeah.
Do a lot of majors require this course?
No major requires this course. This is before, I think you don't get college credit for this course. So like after this course you take pre-calculus and then that will count towards a degree. But if I understand correctly, this course will not count for college credit. So.
You have to take this one to get to.
Yeah, you have to get this, because if you just went to, because basically if you just went to pre-calculus cold from where you are, unless we have failed in placing you, if you're totally bored in here and you feel like you need to go on, you should go back in time, like travel back in time a week before and tell me that then. So, sorry,
So pre-calc, you got pre-calc for one major?
I think pre-calc will serve as like the math, like every major has some kind of math requirement or quantitative literacy. I don't know what language they use here, but there's always some kind of math requirement. So yeah, there's a lot of majors where probably after you take pre-calc, that's kind of like it for math. Now, if you're an engineer or going to like some kind of engineering program or science or something like that, you're going to have more math. I mean, if you're a math major, you're going to have more math. So, does that make sense? So what I'm trying to say is, what you want to get from this course is like a complete and working knowledge of everything we're doing, so that when you go to pre-calculus, it doesn't, ruin your life, right? Because if you learn this stuff well when you go to pre-calculus, it won't be that bad. Because trust me, they're a lot alike. I know, because I keep getting confused about which course I'm teaching this semester, because I'm teaching both. I'm like, did I cover that in there? But no, I mean, they're genuinely different courses, but So let's look at some more examples, unless you guys have a specific question. No? Yes? Okay, so I don't know if I've done one quite like this. Find equation of line through, let's say, -3, 2, and 4, 10. Also graph line. One thing I should have mentioned, since we're talking about the test, is I did say you are allowed a sheet of notes front and back for the test, right? So one of the things I would put on the sheet of notes if I was you is like definition of the equation of a line in its different forms, right? Because we have like 2 or 3 different ways to look at it, right? Should I remind you those? So we have y equals mx plus b. We have y is equal to y1 plus m times x minus x1. We have y is equal to y1 plus y2 minus y1 over x2 minus x1. I may not have told you guys this one yet, I forget. This is slope-intercept. This one is point slope. And this guy is the 2-point formula for a line. The third one is very greedy, and if you use it, it makes this problem have no work to do practically, because all you have to do is plug in the 2 points that you're given, and you'll have the equation of the line immediately. So if you have the 2-point formula for a line on your sheet and you know how to use it, this problem becomes almost trivial. Shall we do it? Yeah. So we're going to let x1, y1 equal to -3, 2. And we're going to let x2, y2 equal to 4, 10. Those are just our choice. So let me just unwrap what that means. x1 equals to -3. y1 equals to 2. x2 is 4. y2 is 10. So then y equal to y1 plus y2 minus y1 over x2 minus x1, x minus x1. I just copied down the formula for the 2-point form of a line again. So there it is. Now I just need to put in what we have. So what does that give me? y1 was 2. y2 is what? 10 minus 2 divided by 4 minus a -3 times parentheses x minus a -3. So I think we can clean that up, right? The thing in square brackets is 8 over 7, right? And so what we have here is 2 plus 8 over 7 times x plus 3. Now, that is one answer, right? You could put a box around this. This is a legitimate answer to the question. But what if I said more? What if I said find the equation of the line, and then I put a little caret here, and I said in slope-intercept form? Then our work would not be done, right? We would still have to simplify this and put it back into the y equals mx plus b format, right? How do we do that? Like distribute, right? So this is equal to 2 plus 8/7 x plus 8/7 of 3. Let's see here. So how many sevenths is 2? 14, right? So 14 plus 24 over 7 plus 8/7 x. And, okay, so we have 8/7 x plus 38 over 7. So there are the answer. Here's your answer in slope-intercept form. What's the graph look like? How do you graph a line? Let me suggest to you the easiest way to graph this line is just to use what we're given. -3, 2, right? That's like here, roughly speaking, right? What's the other point? 4, 10. I don't know, it's up here somewhere. If I had graph paper, we could do better, of course, but I don't, so there it is. And then what does the graph of the line look like? Remember that game we used to play that we liked with the numbers and little dots? And connected the dots, right? Just like that, just connect the dots. Right? That's the line. So the line is that. There you go. That is the y equals to 8 over 7 x plus 38 over 7 line. And can you tell me what this point is right here? What is that point? What's that? It's the y-intercept, right? But what as a point in the Cartesian plane? Like it's fill in the blanks for me. Blank, comma, blank. 0, 5. Now you're just trying to look on the basis of my graph, and that would be a mistake because my graphs are always like not quite right scale because I'm just like freehanded on the board. So you got to use the equations to answer my question. But you're right, it's really close to 5. You're not wrong about that. What was this here? What? Say again? How do we figure out the y-intercept? Oh, plug in 0 for x. I like that. What do we get? If we plug in 0 for x here, what happens? 8 times 0 over 7, which is 0, plus 38 over 7. 38 over 7, Right. This is a 0, comma 38 over 7 is that point right there. The y inner. It's fine. Fine. So, I mean, we say slope intercept. This, whatever number appears here, that is the y-intercept. Okay? I mean, the intercept is b, the slope is m, right? The point we're talking about here is x1, y1. The slope is m, right? And you're right, that is about 5 because, like, you know, this is 5 plus 3. What's that? Yeah, 5 and 3/7, right. 5 plus 3/7. But, you know, my aversion to the mixed numbers. But anyway. All right, so there you go. You good? Okay. So let's do some more with functions. You guys always need more work with that. So here's a graph of a function. All right. And I will tell you that that is -2, 3. I will tell you that this point is 10, comma 1. This guy up here is, I don't know, 4, 8. And just for kicks, I'll throw in another point here. 1, 6. All right, so here we have the graph of a particular function. And now I can ask you questions. So I'm going to ask you to fill in the blank for me. F of -2 equals to what? F of 1 equals to what? F of 4 equals to what? F of 10 equals to what? And just a reminder, here's the basic idea. The basic fact, x, comma f of x is a typical point on the graph of f. So whenever we have a pair on the graph, we can read from that the input and then also the corresponding output. That's what the graph means for us, right? Because the graph is, you know, we have y equals to f of x on the graph, right? I mean, that is what defines the graph. It's the graph of that equation, actually. Remember, it has to satisfy the vertical line test. We talked about this. Uh-oh. It's okay. Probably a birthday call. See here. I mean, I can't complain. I've answered the phone in classes. I have to. I never know when it's something important versus a call to sell me insurance for my car, which I do not either own or need. Anyway, so f of -2 What can you tell me? What's it equal to? What is f of minus 2 equal to? I don't even know. I mean, what might tell us about it is right here. See that circle? That means that it's not exact. It's not a point in the graph, which means this is a trick question. The answer is does not exist. The number minus 2 is not in the domain of the function. F doesn't have to tell you where it goes. Right, if it's not on the graph, that means that it's not in the function. It's not in the domain of the function, so we can't. Same for 4. So 4 is not an element of the domain. You're talking in hieroglyphics again. This symbol here means is not inside. It's not an element of. You can write it out in words if you want. 4 is not inside the domain of f. So this and this are the same sentence. Okay, how about f of 1? What's f of 1 equal to? But did I hear 6? Hooray! Yeah. Up. F of 10 would be 1. You got it. All right. So, next question. What is the domain of this given function? And what is the domain? I'll just give you it in words. It's possible inputs, right? X values. It's the x values on the graph of f, right? In contrast, the range is equal to the y values attained in the graph of f. So for my example here, what's the domain? You guys tell me. X such that what? -2 to 10? I'll take that. How about -2? Is it included? Not included, right? And 10? 10 is included, right? And what? X is what? X is not equal to what? 4, right? So basically, that's the way we could write the domain is that it's x between 2 and 10, 2 not included, 10 included, and x not equal to 4. In interval notation, what's this look like? It's drawn on a number line, right? So you have -2. Let me use the other notation. You have -2 all the way over here to 4. And then you got 4 to 10, right? So the domain of f, we do -2 to 4, not included. unioned with 4 to 10 included. There's the domain written in interval notation, possibly using a union. I mean, we needed the union here, right? Because we couldn't do it with one interval. There's like 2 intervals. We got to join them together to get the domain. How about the range? I'll write it this way. Y such that what? You're telling me?
I'm thinking it's like y2 minus
Oh, I think you're thinking about finding slope at the moment. It's easier than that. It's easier than slope. We just got to look at like what, and so the way you can figure out what the range is like graphically is if you think about horizontal lines slicing through the graph, any horizontal line that hits a point, that's a point that's in the domain. So like, as I look at this one, I've got, I got points, I got points, I got points, I got points, all the way up into here, right? Y equals to 8 is beyond the range. But down here, y equals to 1 is in the range, right? So like I got all the values.
So would it be less than 8,
Greater than or equal to 1, but yeah. And 8 is not included because that hole at the top. And then this is easier to write into interval notation. It's just 1 included to 8. So either one of these is a fine answer. Of course, if in the question I ask you to give your answer in interval notation, then you have to give the answer in interval notation. If I have instructions for a question where I say give the answer in interval notation, right? And the whole question is just about that, then that's worth a lot, right? If I have a question that's got like a lot of moving pieces, and then I say, please give your answer in interval notation, you'd still get like 80% credit for giving the answer correctly in another notation. It would be like a little bit of the credit is the interval notation, a lot of the credit's the other steps. So how important it is to put your answer in interval notation, it depends on the question, right? So I do give partial credit though. So let me show you what I mean by that. Oh, why am I using this? Well, you've seen, we did examples before with like absolute value. Those examples had like a lot of steps, right? So at the very end, we converted the answer to interval notation. That would be what I'm talking about there. That kind of problem, if you gave your answer using inequalities and forgot to do the interval thing at the end, I'd still give you a bunch of partial credit for that. I created a dust cloud up here. Let's see here. Another example. Let's say f of x is 1 over x squared plus 1. Find the domain of f and range of f. Also graph y equals f of x. So how should we graph something like this? I mean, I would probably have more advice. I'd probably say, please make a table of values to graph this, right? I might even say, fill in the table of values. Maybe part of the question would even be, to make my life easier, I would even have this in the problem statement of the thing, Let's see here. So I don't know, we could try, say, minus 10, minus 5, minus 1, 0, 1, and then 5, and then 10. We can fill in this table of values, and then we can find the corresponding graph. And once we do that, I think it'll be easy to answer my questions. I mean, there's one question you could answer here without even doing this table of values or anything else. You could tell me what the domain of the function is. What is the domain of a function? If we give you a formula for the function and we say, what's its domain, what's our rule, how do we figure it out? What's our custom? Given formula, f of x, the domain of f is the set of all x for which f of x is real. So my question to you is, if we think about that formula, 1 over x squared plus 1, when is that formula making sense? Like, is there any way it could be undefined? What's the danger for something like that? Is you could have division by 0, right? Is that possible here? X squared plus 1 could be 0? I mean, we could try. What happens when we try? We get x squared equal to minus 1, right? So x is equal to plus or minus the square root of minus 1. It's something we'll talk about more at the end of the semester in here. I'm getting ahead of the story a little bit, but the long story short of it is, from just common sense, you can tell there's no way you can take a real number squared plus 1 and get 0, right? There's no real solution to that. So what's the domain? The domain is all real numbers because there's no strings attached to this formula. I'm trying to tell you, you could see that without doing anything else. So, but let's plug in the values and we'll make the graph. So what happens when we plug in minus 10? $100 plus 1, yeah, so we get 1 over 101, right? When we plug in 5, minus 5, we get 1 over 26, right? When we plug in minus 1, we get 1 over 2. When we plug in 0, we get 1. And then the pattern repeats because it doesn't matter whether you plug in 5. Oh, I'm sorry I'm getting so small. Let me write my fractions sideways. Is it possible that the domain is just positive, or does it have to be symmetric?
Like how you have your, like you said, like 101, like the top 3, 101, 26, 2, like with the, is it change like the bottom 3 could be like negative?
Well, a different example we could do would be this one. And like if I did that, I would need the domain of that to be 2x plus 1 is positive, right? Well, non-negative. So if I did this one, I might make a table of values like, starting at a half, minus a half, and then maybe I'd do 0, and maybe I'd do a half, maybe I'd do 1, maybe I'd do 2, something like that. Should get me going. So does that answer your question? It doesn't have to be like this. It's just that's a good choice of numbers for this problem.
No, I'm saying it's just, either way the y side be both positive and negative. Or is it just the x?
Yeah, the y could be positive and negative, but not for the second example I just made up.
Yeah, that's all I was trying to make sure.
Anything can happen. It can be plus to plus, it can be minus to plus, it can go back and forth. I mean, like this is a function. You know, that's the graph of a function. Don't ask me to write the formula for it. But, you know, if I made a table of values there, it would be like going plus and then minus, then plus, then minus, and going up and down. And function. Yeah. It's cool. So let's see here. I'm going to use a different scale on the x and the y-axis, all right? So like y-axis, this will be 1. The x-axis, this will be 10. So obviously I'm using, you know, not the same scale on both sides. And so what does my graph look like? It's up here at 1, right? And then when we plug in -1, we get a half. Plug in 1, we get a half. When we plug in 5 or -5, we get 1 over 26, which is like what? It's pretty small, right? It's down here somewhere. It's like 0.05 or something. 0.04, roughly. 1/25 is 0.04, right? And then by the time we get to 10, we're to basically 0.01. Because 1 over 100 and 1 over 101 is really pretty close. So, I mean, to the limits of the resolution of my picture, we're practically on the x-axis, right? And so if you connect the dots here, you see what we're getting. We're getting something like this, right? This is y 1 over x squared plus 1. Good luck with the blue. Sorry. Contrast of blue on this almost black. Well, whatever this is. It's not quite black, is it? It's kind of brown. Yeah. Yeah, I can't even see it. Yeah, that blue is almost imperceptible, isn't it? So I'll use the fine. I was trying to be more interesting here and use some different colors, but maybe I should give up on the colors. All right. Anyway, so we already agreed that the domain of f was -infinity to infinity, right? It's the whole reals. What's the range? What are the possible y outputs? Here, so like, if you think about horizontal lines, they're going to cut through the graph. They cut through the graph, right? And they keep cutting through the graph, right until when? Yeah, they cut through at one point, right? And how about down here? How about y equals to 0? Is there any place where the graph gets to 0? It does not, right? Now, you can try. What's that? What's that? 1 over 101. Yeah, it gets awful close, right? But if we tried to solve the equation, 0 is equal to 1 over x squared plus 1, that's what we'd need to do in order to actually have an intersection of the graph with the x-axis, right? This equation would have to have a solution, but it does not, because if you just multiply that equation by x squared plus 1, which is non-zero, we get 0 equals to 1, which goes to show you it is impossible to have 1 over x squared plus 1 be 0. Because what happens is you get closer and closer and closer to 0, but you don't actually get there, right? So those are what are called horizontal asymptotes. All right. Not a word I expect you to repeat for test 1. It's just I'm sharing it with you because it's something you're going to run into again in like pre-calculus when you get there, okay? So what's the range? You guys told me 1 is included on the upper end, right?
So it'd be 1 over 101.
Well, it goes below 101, though. That's just as far as we got, right? Like, it keeps going. It gets closer, closer, closer to 0, right? I mean, you pick any number you like 1 over a million, and, if I plug in 900, well, if I plug in the square root of 999,999, then f of that is 1 over a million. So we just do this, just 0. 0 is not included, but it gets awful close to it. So that would be the range here. So if I ask you to find the range of a function where I give you the formula has to be simple enough that you could construct the graph either using a table of values, or maybe it's one you already know. Like, you should be able to tell me the range of any linear function. If I ask you what's the range of y equals mx plus b, what's the answer? If I have a line y equals mx plus b, if that's my function, what's the domain? What's the range? What x can you put in? Any x, right? So the domain is all real numbers. How about the range? What y values does it get to? Right, as far as you want, everything, right? So the range is also all real numbers. Now, if some of you guys wanted to trap me, you'd be like, no, sir, you're wrong. Because I can think of an example where that's not the case. Can you tell me the example? What line doesn't have a range, which is all real numbers? Perfectly, exactly. So this guy, y equals to b, that has a domain that's the whole reals, right? If I think about this as being my, say, g of x. Domain of g is all reals, but the range of g is just the set containing b. It's just that one thing. That's the only output. It's just a very boring function. It gives you the same output for every possible input. What's the other kind of line that I haven't talked much about in here at all, but it's actually kind of important? Vertical line, right? And so here's a vertical line. Say x equals to, I'll make it specific, x equals to -2. This vertical line, what's the, if I say that's equal to h of x, should you let me do that? You should not, right? Because a vertical line fails the vertical line test in the worst way possible. Right? I mean, it would be trying to output all real values for the single input of -2. This is not a function. A function has to have one output, right? So vertical lines fall outside our scope. Now, you technically could write a vertical line as a function of y, but as to not confuse the students, we do not talk about functions of y in this course, all right? If you find a homework problem somewhere that they talk about a function of y, you can just skip it. We'll talk about functions of x in here, all right? I hope I'm not just ruling out a bunch of homework problems. It's a risk I'm willing to take. So anyway, hey guys, have a good weekend. I was going to end much earlier, but we got distracted with some stuff, so sorry about that. And happy birthday!